Hi guys, Mr. King here.
Hi guys, Mrs. G.
Alright, this should be the last video of the school year.
We're getting close, Mr. Kane. We're almost to the end of the school year.
Alright, so gas law, stoichiometry, and this is going to be it.
Yep,
Yeah?
we're getting
Okay.
close.
Alright.
Now, this is going to be a toughie. Well,
No, it's stoichiometry,
Yeah.
and it involves gas laws,
right.
right?
You just have to think about it.
Okay, so if I get the concepts,
Right.
this should be okay.
Yes.
Alright. So gas stoichiometry is similar to regular stoich. We could figure that out, right?
Correct.
From the name. But the volumes are given wanted instead of mass. So we're going to be looking for volumes of gases. I could tell that from the words gas law, stoichiometry.
Right. They're either going to give you the volume of the gas, or they're going to ask you for the volume of the gas. Before, stoichiometry was a mass to mole to mole.
Mm-hmm.
Now it's a volume to mole kind of thing.
All right, okay.
So there's a little leg room before and after you do the stoichiometry.
I noticed that the thing that's in common there is that there's a mole-to-mole ratio.
Yeah, any stoichiometric problem we've ever done has always been a mole-to-mole ratio from a balanced chemical equation.
I was just going to say that. I was going to say, so I need a balanced equation?
Correct.
All right, that's good. All right, I'm getting this then.
The start and the end might be different.
But the thing is that since problems aren't at STP, we can't use this fact that we've known previously. 22.4 liters is 1 mole.
No, not every problem is at STP.
So we're not going to be able to use that anymore. Okay.
Not going to be able to use that every time.
But if it says that things are standard temperature and pressure,
Then we got a little shortcut ratio
then
right there.
Then I can use it.
Yes.
Okay. So instead of using that fact, I can use pivnert, right?
Correct.
Because I can calculate the volume or number of moles of a gas from pivnert when things aren't at STP.
Yes.
We can use 22.4 liters equals 1 mole.
Only if the problem says that all the gases are at STP.
1 atmosphere and
0 degrees
0
Celsius, which is 273.15 Kelvin.
If I know those facts, I can apply stoichiometry and pivnert.
Yes.
All right.
You're going to be doing pivnert at the ends and stoich in the middle.
Let's try it out then.
All right. You got a balanced chemical equation. They are all gases.
Ooh, okay. How many grams of ethene gas? Well, which one's ethene?
Well, it's the one that's not oxygen, CO2, or water.
Oh, I know the other ones. You're right. I know that's oxygen, that's carbon
Yep.
dioxide, that's water. Okay, so the ethene must be the C2H2.
Correct.
All right. So how many grams of ethene gas are required to be burned if 1,345 liters of carbon dioxide are produced and the entire reaction is at 28 degrees Celsius and 55.6 millimeters of mercury? Okay.
556.
Oh,
55.6.
what did I say?
You said 55.6.
Oh,
All
555.
right. Now, here's
Yeah.
the trick with gas stoichiometry. Notice that they did not just say, okay, I have 1,340 grams of carbon dioxide, where you would just do molar mass, you would do stoichiometry,
Right, we got
and then
liters
mass
here.
of the thing. They've given you liters, they're giving you volume. You are going to use pivnert to convert from volume of a gas to number of moles of a gas.
Okay. So I've got a volume of 1,345 liters of carbon dioxide, right?
Yep.
I want to know number of moles according to you. So 0.08206 is my R.
Correct.
My temperature is
301.2 based on 6
301.2.
big rules.
okay. And multiply by pressure over here.
Which you need in atmospheres, so that's going to be 0.732
0.732 ATMs.
atmospheres. Yep.
Okay.
Now, if you just do the algebra,
So I'm calculating number of moles
correct. So
of
number
CO2.
of moles, yeah, and I would suggest that little note to yourselves,
All right.
because this gets very involved, is going to be 39.8 moles of CO2.
Okay, and sometimes I write it like this instead of putting the CO2 as a subscript there. I write it over here.
Yeah, so do I. It's just I like to keep track of what I'm finding because you're doing so many steps. This
Okay.
is a multi-step. Now,
So I've got moles of CO2. Every stoichiometry problem is a mole-to-mole ratio.
correct. So now you can do the stoichiometry.
So now I could say 39.8 moles of CO2.
And from
Is-
the balanced chemical equation, we're going to the ethyne. So it's a 2 to 4 ratio.
All right, so 2 moles of ethyne and 4 moles of CO2. So this is going to be 1/2 of my previous answer here.
Correct. Now, and they want it in mass, so the very last ratio.
Oh, I still have to
don't
do one more
forget that,
ratio.
yeah.
Okay, they want mass.
So the very last ratio is the molar mass of ethyne, which is 26.04 grams.
Put a 1 there.
And the answer is 518
518
grams of ethyne.
of C2H2. Okay, so basically in summary, If they tell me a number of liters, I need to know moles because I'm doing stoichiometry.
Correct.
So I've got to use PivNert to give me moles.
Yes.
And once I've been given moles from PivNert, I can then plug that in as stoichiometry and figure out what it is that I want.
Right.
Okay.
And you're going from, technically you're going from volume of a gas to mass of a gas on this one. Ooh, another one. And it's the exact same balanced chemical equation, so that's awesome.
Okay. So here we've got 8,345 liters of ethyne being burned in excess of oxygen. How many liters of gaseous water is produced when the entire reaction is at STP? Ooh, it's at STP.
That's going to give us a nice shortcut.
I don't have to use PivNert here. I could say that 22.4 liters is equal to 1 mole
Of any gas.
Of any gas. And since they're all gases,
Right, we're going from gas to gas.
I can just do regular stoichiometry.
Correct.
Right? So 8,345 liters of C2H2.
I'll change that to moles using 22.4 liters as 1 mole.
22.4 liters is 1 mole.
All right. No, wait, stoichiometry. We're going from ethyne to water.
So moles of water. So moles of water is a 2. Moles of ethyne is a 2.
Oh, this is a boring one.
Yeah, there's not going to be much math here.
And now volume of water using the same ratio.
And since water's a gas here, I can say that it's
And it's at
22.4
STP.
liters of H2O and 1. All right, so
I don't
let's.
even need a calculator.
I'm going to check for things that cancel. Liters and liters cancel.
Yep.
Moles and moles cancel. Moles of water and moles of water cancel. Now the 2 and the 2 cancel, and the 22.4 and the 22.4 cancel. Mrs. G, what's 8,345 times 1 divided by 1 times 1 divided by 1 times 1 divided by 1?
Pretty sure it's 8,345 liters of water. This was a boring one.
Okay, so it's a boring problem, but it gets to the fact that when you're at STP, you can use 22.4 liters is equal
Yep.
to 1 mole.
Yep.
If it's a gas.
Right.
If it's not a gas,
You can't, yeah.
I can't do that. Yeah.
Well, you know, and I mean, think of it logically. If we were going to say, oh, CO2, then it would just be 8345 times 2,
Right.
because it would be a 4 to 2 ratio.
Mm-hmm.
So that's a shortcut that you can only use for gases at STP. How many liters of oxygen gas are required to burn? This is not STP, so something tells me we're going to be doing PivNert.
Yeah, okay, so they're telling me the number of liters of ethyne gas, and they're asking me for liters of
Oh
oxygen
my gosh,
gas.
we're doing PivNert twice. Once at the beginning to get the moles,
And
once at the end to get the moles.
Okay, so
Whoosh!
let me do my first PivNert. PV equals nRT. Okay. My pressure is given as 645 millimeters of mercury. I need that in atmospheres.
645.849 atmospheres.
0.849 atmospheres. The volume, I do know, it's 3.45 liters.
Right.
The number of moles is what I'm looking for. All right, so 0.08206 is R.
Yep, the constant.
And the temperature in Kelvin is?
410. 410.
410. Okay, because I've got the ones place here based on
with a
sig fig
decimal
rules.
place, I guess, if you want to get real particular.
Okay, with a decimal place because the ones
Yeah.
place is my last sig fig. So number of moles of C2H2 winds up being
0.0871 moles.
of C2H2. Okay, so what I'm going to do is I'm going to take that then, 0.0871 moles of C2H2, and I am going to convert that to moles of oxygen gas because that's what we're looking for.
Right, this is the stoichiometry part. The other one was just prep work, if you will.
So 5 moles of oxygen, and the moles of C2H2 is 2, so it's a 5 to 2 ratio. We get,
0.218.
all right, 0.218 moles of oxygen.
Yep, that's the stoich. We just did it.
All right, so now we want liters of oxygen, right?
Yeah.
So we got to do PV equals nRT, this time using oxygen. The pressure is going to be the same pressure, right?
Right.
0.849, because this is happening
at the same temperature and pressure.
The volume is what I don't know, volume of oxygen.
Right, that's what they're asking for.
Number of moles of oxygen is 0.218, that value that we just calculated.
Right, that's what you did for stoichiometry.
0.08206, my R, and my temperature is still 410 with a decimal place.
Right.
All right, so now I do some algebra. I combine my like terms. I divide by 0.849 and
8.64 liters.
okay, that's got 3
And
sig
that's
figs
O2.
of O2.
Yep.
All right. So sometimes I have to do Pivnert once. Sometimes I have to do
Yep.
Pivnert twice.
And sometimes you can get away with 22.4 liters as 1 mole.
Okay, that seems like a pretty decent summary of how we do gas laws.
Stoichiometry, yep.
All right. Very good, guys. See you tomorrow.